In this question, you're given a graph that shows how the weight varies with the mass on two different planets P and Q. So when you see that the y-axis is weight, W, and here the x-axis is mass, you should think of the formula W is equals to mg. Using what you learned from math, this is like your y-axis and this is your x-axis. So y equals to mx. But of course, your m here represents the gradient. So if I were to rewrite my weight formula, W equals to gm, you can see that the x-axis is basically your mass, which is correct over here, and your y-axis is your W, your weight. All right. So that means to say G is basically your gradient of the graph, and gradient is rise over run, which is your W over M. Okay, so gravitational field strength is basically the gradient of these two lines here. So if you find the gradient here, that will be the gravitational field strength of P. So in other words, by looking at the gradient, how steep it is, you should know that the gravitational field strength is much higher than the gravitational field strength of P. It's like this is the Earth, for example, and then this is another planet, for example, or just the Moon, where the gravitational field strength is lower. Now let's go into the question here. The information given to you is that the object weighs, the weight is 200 Newton on planet P, and this same object is taken to Q. Now from your theory, the concept, you must know that, okay, the weight on P, so you were to look at this here, 200 Newton. If you look at the graph here, this will tell you the mass of the object, and you should know that mass is the amount of matter inside the body. It will not change whether it's on planet P or Q. So it becomes very straightforward. So since the mass, if you bring it to planet Q, you'll be using the graph for Q. Mass is still the same, 20. So now when it touches the line for planet Q, you look at the y-axis. The weight of the mass on planet Q will be 100 Newton. So this will be 100 Newton and the mass remains the same. So the answer will be A. Though the question never asks you to find the gravitational field strength, let's just practice it. So G is equals to W over M. I'm referring to the gravitational field strength for P, planet P, and I can take any value, any nice value. All right, so let's say I take this point here, is 400 over 40. That will be 10 Newton per kg, which is equivalent to the gravitational field strength of Earth. And for planet Q, the G for the Q, I can likewise take any of the nice point here. Okay, let's take maybe the last one also. 400 divided by 80, and you realize that that will be half the gravitational field strength. All right.